So it turns out it's not very easy, and I've done 2 startups, and it turns out it's not actually what professors are paid to do. So I no longer think this is actually the reason. So if it's not a system or an app, then of course we think, well, we do research to create knowledge. But it turns out it's also very difficult to get this knowledge beyond academe. So we're all good at writing papers, or many of us are good at writing papers, into the hands of industry, designers and developers who could actually use this information. And I've spent a lot of time on this, and we'll talk about it a bit at the end, but it's still not the driving force of why I personally do research. So if not getting knowledge to industry, maybe it's getting knowledge to government. So I just wrote a CIFAR policy briefing on AI and kids, and I do feel a little bit that I'm steering the ship a tiny little bit, and that is one of the main reasons that I now do early stage innovation HCI research, is because I want to steer the ship. So I think that the kinds of projects and the approach that I take set an example of not what can be done, but what should be done and how it should be done. And essentially a steering through example of looking at the kinds of research topics we think are important to study and the ways we think they should be studied. So that's actually why I do research at this point. And sometimes it is helpful to reflect on for all of you why you do research. So that's a little backdrop. Okay, so in my lab, we're committed to working with diverse populations of children, particularly those that might be vulnerable or really difficult to reach. We do this in areas where there are challenges they face have large negative impacts on their well-being, and this means that much of my research is both high risk, but also high reward. So many of the challenges that kids face need to be addressed in an interdisciplinary approach, so we're going to talk a bit about that. And as I said, I'm really interested in emerging technologies and showcasing what we should be doing, or what I think we should be doing as proof of concepts, rather than what we can do. And then there's also a commitment in my work to community-based approaches, and we'll delve into that as well in the talk. And so the overall contribution, I think, of my work, and I think of myself as a design researcher, which is slightly different than an HCI researcher, is opening up design spaces through work. Okay, so research generates knowledge, and in my case, I focus on knowledge about how do we support children's well-being using different emergent technologies. So it's good to know what well-being is. We all have our different ideas about that, but it involves physical health, mental stability, positive emotional states. So some of my work, a good chunk of my work, deals with emotion regulation skills, which are critical to well-being in children's development. Well-being is often social and linked to loving others, being supported by families and friends. So another group of my work has to do with parent-child and co-design methods. And then well-being is also correlated with different forms of literacy, language, technology literacy, environmental literacy. So I have projects and I have worked in all of those areas, and we'll talk a bit about language literacy today. So the framework I want to talk about has 5 interwoven components. And I'm going to tease it a little apart, give you some examples. It's going to be like the 10,000-foot view, so hold on to your seats. We'll start with theory. So in child-computer interaction, there is so much we know about child development and learning. So we are going to look at it depends on the project, but we're going to look at cognition, emotion, mental health research. We weave in ethics and philosophy. So depending on the challenge that we're addressing, theory matters. And there's so much we know and so much we can build on. So that's one of the pieces of the framework. This one is less interesting to some of you, perhaps just kind of a given, which is that we're going to do technical innovation. We're working in spaces where systems don't exist. So we have to make them. And we're looking to see which ones have merit to explore them further. Evaluation in HCI was traditionally quantitative and experimental, and this does give us measures of efficacy if we're trying to improve various aspects of well-being. But in design research, what I'm interested in is looking at qualitative measures in messy field studies to really see what's going on and what we can do. So we end up with mixed methods field evaluations. So that's the third component. And then there's two more really important pieces of any research design that I do, and one is participatory design methods. And so although these methods traditionally came from product design in Scandinavia, in the child-computer interaction community, they have evolved as a way to include children's voices in the technologies that are going to impact them. And it's actually both pragmatic, we'll talk about why this is a good idea, but also for me, it's an ethical stance. And speaking of ethics, from beginning to end, I consider and reflect on ethical issues that arise with emerging technologies and research and working to mitigate negative impacts for kids. And I think ethics has become a way where I also feel strongly that I can steer by example. So there's this 5-part framework, and we're going to unpack it. So I like to say we mine theory, which is metaphor, and in different ways. And so the first way, which is the way we often see in HCI, is really high level. So people frame their research design approach about what we know, specific areas of well-being we're interested in, kind of a broad foundational background. And then from there, we can work into really specific learning or developmental goals that we have, depending on the problem we're trying to solve, the challenge that we're addressing with children. And this also allows us to drive very specific targets. And then theory also helps us in terms of designing new systems to identify mechanisms. So the mechanisms, what I mean is human processes that we have, or we have a hunch that a particular technology-mediated intervention could support, augment, enable in some way that's going to help us reach these targets with kids and therefore address the challenges that they have. That sounds very simple, doesn't it? And then the last place I use theory quite extensively is to look to have valid and reliable measures to see, like, how we winning? Did we get where we thought we wanted to go? So theory looks like that. Let's get a bit more specific. So again, it's really an overarching lens that I start with, and some people never get past this point. So using theory is hard. I talk to my grad students, I say, figuring out how to use theory as an interaction designer and as an HCI researcher is actually not that easy. It's super easy to say, oh, Vygotsky and I, we've been reading and we're gonna, but to actually drill down. So we'll talk about that. But it is also important. So I think the starting place is always this thinking about what we're supporting the development of. And sometimes in any given project, we might be looking at their characteristics of children. So we want to have a mastery mindset, which is quite different than having exploding balloons as rewards, for example. So we know a lot about mastery or a sense of agency and resiliency. So these things underlie almost all of my projects. We might be interested in particular skills. These could be emotion regulation skills or language literacy skills, critical reflection. And sometimes we need to teach kids knowledge along the way to do these things. What are emotion regulation strategies? And then the skill to actually do it. So this is all kind of a really good starting point for theory. And I do, so that just took 4 months, but it's not enough. So let's look at a project, and I'm going to walk through the more specific ways that I use theory in research design. And this is a project on early language acquisition, and it's for children with dyslexia. So dyslexia is a severe challenge learning to read and write in various languages. And we have a number, for all of these papers, we have all of these projects, we have a number of papers. And at the end, we're going to kind of unpack how do we end up publishing all these different kinds of papers that we do. Okay. This is the project. This is what we're tackling. In English, 1 in 10 people have dyslexia, severe ability to learn to read and write, and it starts in kindergarten. It starts as soon as they start to learn to read and write. People like Albert Einstein, Agatha Christie, and somebody helped them, and hundreds of hours need to go into these things. So I wondered, is there a way? This is like a big challenge for kids. And of course, if you're in a marginalized situation, it's even worse because you're not going to have access to tutors and special programs at school. So I wondered if there was a way that technology could make it less resource intensive. We can kind of get there, but it just takes a huge amount of time and resources. So this is a problem we're solving if we care about children's well-being. And literacy is critical to well-being in so many ways: education, self-esteem, mental health, social interaction, entertainment, their economic status later in life. Okay, so back to theory. So we come down and we start to think about, we have these theories around early language acquisition. We know things about interventions for dyslexia. There's our framing. And now we're going to dig more specifically and think about using theory to generate learning goals. What do we want to do here? So there's lots of things. Early language acquisition is a massive field. What we want to do is improve 7 to 8-year-olds, children who have dyslexia's ability to spell and read simple words. And it turns out there's 7 rules of the alphabetic principle, super handy for learning to read and write English. And this is a place we know they get stuck. So that's our learning goal. And from there, we can create a research question. And in this case, I had a hunch that a tangible user interface was going to be a good idea, which is counterintuitive since they've mostly only been used for spatial domains, not for language. But I had some thoughts about this. And so my overarching research question becomes, how can a tangible user interface to a custom reading application enable to improve 7 to 8-year-olds children with dyslexia, blah, 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 blah. So you sort of go from the learning goal to the research question. And then I really like to be specific. So I like research questions that I can answer with data and not in a kind of amorphous way. So we really need to drill down further into theory. And to that, I learned that we want to think about 3 different targets. One is learning gain. So this is actually quite straightforward: spelling and reading accuracy on a curriculum-based word set. Learning transfer. This is often neglected in educational work with kids. Spelling and reading on new words. So of course they're going to learn the words we teach them, but now what happens? Can they apply these rules when they're reading, when they're in their classroom? And then the last one is, does it last? Maintenance, which also is often neglected. So these become our specific targets, and we're drawing these from theory. This is what success looks like. If we can do this for kids who've failed multiple levels of interventions for dyslexia, we're winning. Okay, so we also use theory, we said, to figure out what's wrong, what's the problem, and then what are the mechanisms we might support. And so we dig into challenges and causes of dyslexia, looking at theory, and we want to identify mechanisms. And the question I ask myself, this is not a research question, this is what I'm trying to figure out as a designer, is what mechanisms can I support that improve learning, reading, spell for children with dyslexia? And from that, I'm going to take those mechanisms and think about the way technology could augment or support and drive design strategies. And I think of these as working hypotheses to see. Let's just see how it goes. Okay, so theory tells us that in this case, we'll just demonstrate with this project, that causes of dyslexia are poor phonological awareness, which is the ability to hear sounds and relate those sounds to letters, and also small groups of letters, which are called phonemes. So one of the problems is that they can't hear sounds and associate that with the symbols for letters. They just really struggle there. There's also attentional issues, often correlated. And then English is just a bugger of a language. For many of you, you might have to learn it. So one letter can make more than one sound. Two letters together can make more than one sound. So dyslexia doesn't exist in languages that have transparent orthography, but it certainly exists in English. Okay, so this gives us some clues. What are the mechanisms? What are we going to do? So we have these things, and we think, okay, so that seems kind of straightforward. If we can improve the way they hear and understand letter-sound correspondences, we're going to make some progress. And if we can help them focus attention on the way that letters change the sounds in words, depending on where the letters are in the word, according to these rules, which are called the alphabetic principle. So far, this just sounds so great, but why is nobody doing this, right? Okay, so then I want to think about how am I going to use some technology. In this case, I had a hunch that tangibility was going to help us to derive design strategies that focus on these different mechanisms. Okay, so this is the first design strategy we came up with, which was to use dynamic letter cues. We want to change the color of letters, and it's tangible, so we're going to use physical letters. So what we saw, what you'll see on the left side is this is what happens when people print. Tutors are teaching kids on paper, and they're printing. They use color. But I argued they didn't use it very effectively, and it's static. So they might have, in this case, When I look at these, I'm like, I don't even know why the E and the T are both pink. It doesn't make no sense to me. And so, and what are they doing there? But if you look at the dynamic colors, so let's say we're trying to spell words that have, when you add the E on the end, change the vowel sound from short, which is yellow, the A sound for an A, to long, A, in game, then all of a sudden you start to say, oh, okay, so when you first put the A down, it's going to be short, and then we add this trailing E on, the letter's going to change color and indicate that it's a different kind of vowel sound, where yellow represents short vowels and red represents long vowels. Are you following? Okay, so that's the first strategy. Turns out it's a critical strategy. There's a few other things. So I had this kind of, you could have done that on a graphical screen, but I had a hunch, and I've been working in tangibles for a while, that that feel and spatial organization, things might actually matter. So we looked at theory again, back to theory, and we look at multimodal processing and attentional theories, and it turns out that having multiple sensory representations is really helpful for kids with dyslexia. So if one's not, if the color's not working as well, maybe the shape of the letters working and the spatial organization. So we're going to engage simultaneous use of multiple senses in learning to read. And this might help with some of the attentional deficits. And so we're going to draw attention to these different modalities. And that's entirely different than learning to print on a piece of paper. It's a white piece of paper with a pencil, which is black or gray. And then you've mixed in this whole other skill of having to do fine motor skills and draw symbols. So we're going to have objects that are letters. And then the last part was from some prior work that I had done out of my own work, which is this idea of epistemic strategies. So an epistemic strategy is when we offload something that's really tough in our heads into the world. So the classic example is if I handed you a photograph, a paper photograph, or maybe on your cell phone now, with landscape stuck on, and I put it upside down. So what would you do? Maybe if I said, who is this? And it's upside down. Anyone? You'd flip it. So instead of trying to do it in my head, flip the image in my head, I flip it in the world. So that's what an epistemic action is. And I had this idea watching kids play with fridge magnets, little letters on fridge magnets, that I'm going to get rid of this task of printing and the written word, and we're actually going to allow them to develop epistemic strategies to learn how to spell using tangible letters. Okay, and I don't have time to talk about this, but when we're designing a learning application, there's 100 other things that have to go in terms of best practices. So the research question was a tangible user interface to a learning application, a learning reading application. So that had to get built, and it's not a small thing, but it's not what I'm doing research about. So that has to be right, but it doesn't have to be the thing I'm studying in this case. Okay. So switch gears for a minute. So we've been using theory, and the last place I use theory are my measures. How do we know we're winning? So we've got targets, we've got mechanisms we can enhance. Now we need to collect some data to answer our research questions, and we need to collect data tied to measures. So the standard outcome measures are usually quantitative, and they look at things like, we're looking at efficacy. Can they learn to spell better? It's not too complicated, but as a researcher that's interested in design and behavior and how technologies support our behaviors and our thoughts, I'm really interested in what I call process measures, which are the behaviors that happen along the way. So we need to look at outcome measures, process or behavioral measures, and then I'm also interested in the interrelationship. So if you have these learning processes, do they correspond to certain outcomes? So that interaction effect. And then all of that is like, oh, right, but we're building a system and we have these design strategies. So is there a correlation between outcome measures, process measures, the interaction between them, and the design strategies, which were implemented as features? And if there are, then we can start to derive design guidance about how useful tangibles are for helping kids with dyslexia. Following? So that's the last way we use theory. So theory is just absolutely fundamental to the work I do. And one of the things I see in my field in child-computer interaction, and you might see in HCI more broadly, is a not great use of theory, or they just don't know what to do with it. Like, it's so interesting reading about Piaget or Vygotsky or whatever learning theory is exciting for today, but what do you do with it? So here's 4 things that you do with theory. Okay, so we called this system phonoblocks, which it'll start to make sense. And just to give an example, our outcome measures, which are quantitative, are spelling accuracy, and then we have specific research questions coming in. Do children improve word spelling accuracy after instruction on trained words, the words we're teaching them, new words? So that's the learning transfer, and both after a month. So after a month, we'll give them the words they have learned. We taught them some words they've never seen before, and we look at learning maintenance. So this research question deals with all three of those constructs, and it's quantitative. But as I said, I'm also interested in process or behavioral data. So how do children interact or behave with the system in ways that may benefit spelling? So this is going to be much more qualitative, emergent, and we'll talk a bit more about that later. And then that interrelationship, so it becomes a mixed methods question. What are the key design factors by kind of correlate the process measures and your outcome measures? So all this from theory so far. Okay, so recap. There's 4 ways we use theory. Framing, learning goals, digging into specific targets, the mechanisms we're going to augment with technology via design strategies, and then we just measure and see how it went. So that seems pretty straightforward, I imagine. Okay. But in contrast that, sometimes we see studies coming out of technical fields where they've built a system. It's a bit of a black box, and it might work, but we don't know why. So I care why. I want to know why, because I'm trying to open up these design spaces and say, these technologies have these kinds of features. They can augment our behavior, or our thinking, or feeling in certain ways, and so that becomes valuable. It's a little bit different. Okay, so the second part of the framework always involves designing and implementing the technology part of an intervention. So there's the things you do with kids, and then there's the technology, and they're not entirely separable, but we do have to have a technical system that works. And I'm a pretty strong conceptual thinker. I do have an engineering background, but I try not to be daunted by reality. So the fact that I have this idea for this system where these letters are going to change color, or other things we'll get into, and it doesn't exist yet, it's like, this is an implementation problem. We'll figure it out. And mostly we do. So lots of custom work, lots of innovation, and our requirements are being driven by these theoretical mechanisms and then the design strategies that we've come up with. So I think about prototypes. When I'm prototyping, it's an instantiation of theory. And I also think of them as a research tool to study feasibility and efficacy of these mechanisms that I think might be beneficial for solving a particular problem with this class of technology. And ultimately, they generate design knowledge, which then other people can go use to design for this class of technology, or we decide it was a really bad idea. Okay, so for phonoblocks, it involved hardware and software engineering at the service of creating a research instrument that highlights these interactional opportunities for these mechanisms that we thought might be super useful. So we're trying to deal with phonological awareness, attention. We have this dynamic color cue ideas. We want to have tangible letters. And we just put all this together and build a custom system. So there's nothing particularly innovative in my mind here. It just hadn't been done yet. Okay, so the overall system, I absolutely do not have time. I'd love to get into it. There's a really good CHI paper that talks about this. We can see we've got a touch laptop. Can't have a keyboard, obviously. So we have a touch laptop. It's got some features on it. And then you've got this letter building board and these little plastic letters that go into that. And there's all sorts of features, as you can see in the diagram. So let's just unpack the ones we really care about. So there's lots of things we don't care about as a researcher, but there's ones that we really do care, we think are going to be useful. And just people always say, well, like, how did you do this thing? I was like, I don't know. We just did some agile programming. We whipped through iterative prototyping. We tried different things. We showed it to kids. We showed it to experts. And we'll talk a bit more about the actual nuts and bolts of design, which is a different pillar of my framework. But right now, let's focus on how we made it work. Okay, so the first thing that turned out to be actually really important was the physical letters themselves. So we ended up with lowercase letters. That decision was actually incredibly important. They're semi-transparent acrylic. They're exactly the right size for 7 to 8-year-old hands to play with. They have hard edges that support tracing the letter shapes. You can immediately, when they're not even looking at them and they're not really paying attention, but they're fiddling with what's in their hands, they can tell that their finger has gone over the edge and they're tracing the letters. So they're getting a different kind of modal interaction with letters. And each of them is fixed on a little acrylic base that enables them to stand up nicely and then to fit into the word-making platform. So we had to design those, which is kind of an industrial design problem, not too hard. And then the dynamic color cues were a little bit trickier. And so each of these plastic letters contains a programmable LED strip. And each letter has a unique arrangement of electronic pogo pins on the bottom, which you can see here on the letter base, and it serves as its unique ID. And so the input platform contains Arduino microprocessor that can identify the letter, and it passes on the letter's identity and its location, the slot number, to a custom application running in Unity on the laptop in the background behind the reading application. So when a letter is inserted into a slot, information about its context, the number, which other letters are there also is all sent, and then the system's going to respond based on that. So it's a pretty straightforward technical implementation of the design strategy, it turns out. Of course, it took us a while to get it right. Okay. So here's kind of the end result with these two screens. So this design enables seeing, so this is the game example again. So if you've got the G and the M go in, they turn blue for consonants, and then the A goes in, it's going to turn yellow because it's going to be a soft vowel sound. It enables you to see color change in real time and to hear it, because the system also has a sound display as you add the letters. So as you add that trailing E in the second image, the A flashes to grab your attention. It turns red to signify, oh, now it's and the kids learn very quickly, this is a long letter, this is a long vowel sound. And then the E actually ends up going transparent to show that it's not making a long vowel sound once it's done its job. And the system says, game. And you can also, we can do it backwards too, where it can sound out all the letters. So there's what it looks like in action. And then it also enables selective attention. So as you can just, in these simple examples, you see kids are like tracing, they're putting their hands to group things together. We've got spatial organization happening and hand tracing. So these are the things that we thought, these were our working hypotheses, that these things might be important. So we had to build a system to do these things, to deal with the letter sound correspondences, the attentional issues, and we ended up with 7 roles. So we have 7 sets of spelling words. Okay, oops. I'm going to give you a different example that was a tiny bit harder, but the same idea where to me, like the technical work is just trying to create a system to instantiate theory through these working hypotheses. So this is a completely different project that I was asked to do in Nepal. And yeah, so this one we actually did have to make the system work in ways that nobody had any idea how to do. So it was a chance encounter, this whole project, and I can get into a tiny bit. But my goal was to support young children living in poverty with trauma to learn to emotion regulate. So what I mean is the ability to calm down versus be anxious, and the ability to focus through sustained attention so they could do better at school. Because children who have suffered trauma do really badly at school, not because they're not bright or they're not interested. All the things is they can't emotion regulate. They're anxious, they can't focus. So again, we can talk about the kinds of papers you can write. There's design papers, there's technical papers, all the pieces. But in this case, we never wrote the technical paper, though we did look at doing a patent for it, but it was pretty, again, I think it was pretty straightforward. So we have this goal, we have our targets, improved ability to calm down and focus attention. We'll just flip through those. So those all came from theory, same idea. And then again, like what are the mechanisms? And so in this case, there were 2 kind of key mechanisms. And this was drawn partly from theory, but partly from my own experience of working with children, which is that all children actually already know how to calm down. If you've read them a bedtime story at night, they know how to calm down, and they know how to focus their attention. So instead of trying to teach them how to do something by telling them how to do something, why don't we get them to do what they already know and then give them feedback that they're doing it right? Well, it turns out to give them feedback to doing it right, you end up needing a brain-computer interface. So I was like, okay, let's build one. And so our mechanisms are this practice of feeling like. So instead of starting top down, do this, we're going to say, let's just feel what it feels like to do these things. And we're going to learn backwards. And then we're going to make invisible brain processes visible in a way that you understand when you're a 6-year-old living in the slums in Nepal. It's a very straightforward design challenge. Okay, so we came up with design strategies. If you're interested, there's a whole paper on that. I don't have time here to get into it. And then, of course, there's all the other things. What do we know about teaching kids emotion regulation? Let's build all that in. And we end up with this system. So Mindful is composed of Android tablets at this time, so this is about 10 years ago, NeuroSky EEG headset. It's a single dry sensor for a prefrontal site, very straightforward headset because we're dealing with little guys who have suffered trauma, like their parents were shot in civil wars. Like these are not kids who are going to sit still and let you put the whole thing on, right? But it does sense brave waves associated with anxiety and attention at a reasonably fidel level of accuracy that we can use. So we send that to the app running on a tablet, and we've got software. So again, we've got to have user management, user progress, user history, and 3 simple games in which they can get feedback on how they're doing at calming down and focusing their attention. So we have this system. So this system doesn't exist yet at this time. And we did build the second version. We ran a whole second study in Canada. So we come up with the game concepts. Again, we're instantiating these design strategies that we've hypothesized will support these mechanisms that are going to help these kids learn how to emotion regulate. Each game is built on a familiar everyday activity that these kids knew, so I spent quite a bit of time understanding their world. What's familiar? Where do they calm down? Oh, they calm down when they're blowing on a pinwheel. So as you breathe and you blow on a pinwheel, which all these kids were making them out of these old milk cartons, then you just slowly blow, you just slowly calm down. So building these into games. And the NeuroSky headset monitors their brainwave activity. It uses this pre-processed data outputs for either relaxation or attention, and it sends that to the game. And if they're calming down and they're blowing on the screen, they don't even know what a laptop is, right? So they're blowing our tablet. In this case, it was an Android tablet. They're blowing in the Android tablet, and then the pinwheel starts to spin. And they get this feedback that they're doing it right. Okay, we haven't built the system yet, right? So there was a few challenges besides all the obvious challenges. You have lots of work to get the user interface and the flow correct and the learning design correct. And then we're also running this with people who are not technologically savvy. But the 2 technical innovation pieces, one is that there was actually no way to connect the headset to the Android tablet. And we had to use we'll get into why we had to use Android. We had to use tablets. We couldn't run laptops. There wasn't enough power. We had to use solar chargers. The internet was unstable, so we ended up using Wi-Fi direct. Lots of reasons we had to use a tablet, but the headset did not at that point connect. So this is just a software engineering problem in my mind. So it's like, okay, let's build a custom Java bridge. We're going to make this happen. It takes a while to get it fast enough and not lossy with the data. So that one wasn't too bad. We got it working. And then later they came out with APIs for Android, of course. So it's always the way when you're doing early stage work is 2 years later, Microsoft just releases it and you're like, okay, thanks for that. Could you have done that like 2 years ago? And so the second challenge is a little trickier. So I don't know, has anyone worked with brain-computer interfaces, EEG? So one of the things that's really challenging is you have to calibrate them for individuals. And how you calibrate them is you say to someone, okay, I want you to be really calm and let's see what your brainwaves look like. And I want you to focus your attention and we'll see what your brainwaves look like. So can you see the problem with this? So we have 6-year-olds who are like, they can't do that. So how are we going to calibrate the EEG data for the games? That's our second problem. So this is our end user. And she is actually sitting calmly and doing things about 5 weeks into the 6-week thing. So one of the challenges is that we couldn't calibrate the data ahead of time, which is what you're supposed to do with an EEG, because they can't do the thing. It's a catch-22. So what we built on a second tablet is we developed real-time calibration. So all they have to do is have the headset on and be doing something, looking at the games, doing something with the games, and we can see what's happening with their data, and we can get a sense, and then we can say something like, hey, just take a deep breath, and they can do that. And then you just see what happens and what range they're in. And so we ended up being able to calibrate in real time, which is what we had to do. And the other thing that actually worked out really well was it also allowed, so kids having a really bad day, some really horrible thing happened to them on the way to school, which is not that unusual, and there's just no way. But we don't want them to fail because we have a mastery mindset. We're not trying to get them to win the game. That's where the overall framing comes in. We care about mastery, we care about practice. And so there's just no way they're going to win the game if we don't do something to the game, like make it way easier today. And that's more important on that particular day. So this module allowed us to do that in real time, and it happens with the child not even knowing it's happening behind the scenes. And the counselors who are working with the kids make that call. Okay, so then we end up with this. We've got the NeuroSky MindWave EEG connected via Bluetooth to a Samsung Android tablet back when it was Galaxy 10. It's running Unity 3D. We've got all these modules for login. Oh, we have to do login with photographs because nobody can write and nobody speaks English. And then there's the 3 games. So we've got a pinwheel game, a paraglider game, and a stone game. And then the second tablet was connected using Wi-Fi Direct because of internet instability, and it runs the calibration in real time. So here, technical innovation to me is sort of at the service of making a research instrument, because I'm like, oh yeah, was this idea of experiential learning going to work? And then providing feedback on what's happening in their brains in a way they could make some sense of, like blowing on a pinwheel. So that's what I care about. So we just had to make the system work. So there's sort of a joke in my lab, so we just make it work, right? Like just figure it out and keep working and working at it. And sometimes you do have these innovations that come out of that. Okay, so those are 2 pieces. And let's have a catch our breath on the wild ride. So we've got theory. We use in 4 different ways. We sometimes have technical innovation. Oh, right, you have to design these things somehow. So we're going to talk a bit about that, the design methods and how we do that, which are often participatory in my work. And this is not a linear process. These things are all happening interwoven with each other, but I have to talk about them in linear order. Okay, so there's 3 reasons that I use participatory design methods in my work. And the first reason is to actually create a better research instrument. So it's very pragmatic. If I'm working with end users and their caregivers and teachers and counselors and people, it's just going to be better. So that's a pragmatic reason. And then like the design of it as a research instrument is going to be better. The usability and engagement for kids is going to be better because I've had them working on it. I see what works, what they don't understand, what they're confused about, what's boring them to tears, all these things. So that's also very pragmatic. But the reason that I think is most important is that I actually think there's this ethical stance that it's really critical to include children's voices in the technologies that are going to impact them. And so I could do this research without doing that. I don't believe that's a good idea, and that's a judgment call on my part. Okay, so for phonoblocks, it was pretty straightforward. We wanted to make a better research instrument, so we were doing this rapid lo-fi and iterative prototyping, and we were showing it to experts in early language acquisition really early on, and then working with dyslexia teachers at a school. We were showing them storyboards. We weren't even showing them. As soon as we showed them a system, they just went like, oh, it's technology. So we did it in a storyboard form that worked for them, and we got lots and lots of input early. So this is just a pragmatic reason, but it's not a small thing. It's super important. Human-centered design, user-centered design. Again, so this case we were testing on the touch screen with kids, just making sure all the basic things could work. The facilitators could run the study. That's not a small thing. Again, very pragmatic. So in this particular project, but let's go to Nepal now. So we're working in different culture, and we're working with marginalized children, and so we're doing this crazy ass experiment, right? And it's like, well, what if it fails? Like, then what? And so there's this sort of ethical stance here to the whole. They were driven by their community. Like I was working with someone there, and we had this sort of crazy idea, and she was like, I think that the school I work with would like this crazy idea, and I've been coaching them on all these ideas. This is a fit with what I'm trying to get them to do. We're using experimental learning. We're trying to get kids to emotion regulate because we're not able to educate them. So I spent a lot of time with that community, and I really worked with them to set the goals for the project from the very beginning. I was like, I'm not doing anything. And going in, and I think this is just so important all the way through. So in this picture, I'm just working with the head of the school and the two main counselors, and then the main counselor from Canada who trains the counselors there. Okay, so some of the things that came out of that is that I was forced to explain these mechanisms in ways that they could understand, and then co-design and test the intervention with them in a way, because they're the ones who are going to be running it. They're the ones that I leave behind when I go home at the end of the day. It's their kids. They have ways that they do counseling, and so really, really important. They're also going to be involved in data collection for me. So we taught them how to assess kids in order to collect data. about that. So how do we know if our kids are getting better at regulating their attention and anxiety? How would you assess that? So this becomes like pro D for them in some ways, and I think that's really important. Okay, two more examples, and again, just quickly, there's papers and papers and papers on these things, so super happy if you're interested. So this is a project on virtual reality, mental health, and marginalized youth. Okay, so we're talking grade 9, grade 10, and we worked with them through co-design methods, trying to think about, we started with a systematic review, like what do we know about, we were working on a particular area called cognitive reappraisal, which is if you have a terrible feeling, you can think about it differently to change the feeling, right? So, so classic examples, the weather here, it's pouring rain, and you can just be like, oh my God, it's pouring rain, I'm from Vancouver, it rains all the time. Or you could go, that is so fantastic because there's not gonna be many forest fires, and all of a sudden your affect, your emotion changes. So that's cognitive reappraisal. This is what we're working on with these kids. And so how are we going to do that? So we wanted them to share sensitive challenges in their mental health that were affecting their mental health and help us design a virtual reality applications to deal with that, which is a very body-based thing. And so if any of you have teens, worked with teens, we're recently a teen. So we're trying to get them in front of their peers to talk about mental health challenges and their big emotions and what they might do about it. It's impossible unless you work with a theater class. And then it is possible because they're actually trained to do these kinds of things and they have a safe space. So they already have spent most of the school year creating a safe place to be other people. So we said, we just want you to be other people that happen to be yourselves and to act these things out for us using techniques they already had. So this is co-design. And so again, this becomes some of the requirements and some of the features that we ended up building into our system. And then the last piece, and this was a NSERC Alliance grant with, some of you were at lunch today, and Linda Brown-Ganzert was there with her company. She's the CEO of a company at that time called Curatio, and they build private social networks. And during the pandemic, they were really interested in how private social networks could be used to support children, through children, their families during COVID. And so again, we went to children and their families and write lots of papers. And then we had to do this remotely. So totally different method. So in this case, we can't even be in the same room with them. But we've spent a lot of years doing these things. So we create this narrative framing of a future pandemic. And we want these kids to identify the negative feelings they might have, that this future kids might have, one exercise, and then from there we riff off that and they start being inventors of the future and inventing solutions that would help them, and then bring that into their home and meet with their parents. So now they're in a power position with their parents to talk about these things, and out of that we get all sorts of really interesting ideas and information about what's impacting them. Take that back to the company and do a series of workshops with broad stakeholders, people in product development and marketing, the tech developers, the designers, and bringing those, trying to think what kind of features of the private social network could be useful for that. So this is why we involve our communities in the projects that we do. There's just no way you could do this work in a way that was authentic or, in my mind, ethical without doing this. Okay, so there's three pieces of the framework. And now a miracle has happened, and we have all the theory has been instantiated into a system and an intervention, and then we've designed that with our communities, and we're ready to go. Let's see if it worked, right? So how do we do that? What we're looking for is evidence of the effectiveness of supporting theoretical mechanisms, and we're going to use, back to theory, we're going to use our outcome measures. Did it work? And very, very specific, and we've already defined what that data looks like. What are the behaviors we're looking for? What are those relationships? And then is there a correlation with design features? So you have to look to mix methods. You have to have quant and qual together to be able to do this. So you have to wear those hats. And so this is, again, where interdisciplinary work, you just need different partners. So I don't think someone who is really skilled at statistics should be going, okay, now I'm going to learn qualitative data analysis. No, no, no. There's people who are really good at that, and you partner with them. Okay. We also run all our studies in the field, and I know in HCI we often run stuff in the lab, but the messiness happens in the world, and I think that that's really important for creating design knowledge. Okay, so from the quantitative analysis, it really tells us if we've met our targets. So here's where I show you the horrible tables of multivariate statistics. And this is what gets paper into Chi, is that we can do this. So this one was on spelling accuracy, and we're looking at all our different measures. Here's another one, if that wasn't enough, one on reading. So again, is it effective? So yeah, I have to be an expert in this, or you have to have an expert on your team in multivariate analysis. Sometimes there are no measures. And so there's this kind of nasty habit that I've seen where we'll go, oh, just make some questions up. And we'll just ask those questions. And I'm not an advocate for that. So we did have to create some new measures for various reasons for mindful in Nepal. There were no measures about, there was like, could you play the games? There were diagnostic measures, which people often confuse with measures that are sensitive enough to see if there's been change over an intervention. We're not trying to diagnose them if they have an anxiety disorder. We're trying to see, did we shift them? Did they change? And we're doing this in Nepal, and then we did it in a low socioeconomic area in Vancouver. So we're working with teachers and parents. Teachers are overloaded. The parents has to be very tractable to them. So we can make new questions. We can base it on what we know from theory, and then we validate them. We run reliability analysis. We do construct validity. We don't just make new questions. So sometimes that has to happen, and then you just get more horrible tables at the end of the day when you run the multivariate stats. So these are all outcome measures. And then qualitative data, you're going to look at verbalizations, physical actions, social interactions. This is where you need that qualitative psychology researcher on your team to be able to code this data. And you can do it deductively, going in, I'm looking for these, I know what the mechanisms are, I have this whole, my design strategies are hypotheses, and so I know what I'm looking for, and you see things you might be looking for. You always see things you're not looking for, so then you also have to do inductive coding. And this case was this really interesting thing when kids were learning to spell words, they would use one hand and they would put the letters sometimes in the wrong order and make all sorts of mistakes. And eventually they just pick up the letters and they'd go like this, and they just put them in the word making thing. And then they start crossing, like if the letters were backwards, they would just cross their hands. And we started to go, oh, that's when they get it. So these interesting things pop out and you miss that if you don't do this kind of more inductive approach. Okay, somehow a miracle happens and we figure out what that means for design. So let's just break that down a bit and then we'll just wrap up. So well, we have one more piece and then we'll wrap up. So is this design space feasible? Can we even do it? Can we even pull this off? If yes, great. Let's do more prototypes as a community of researchers. Let's do more studies. Did it seem like it might have worked? Yes, then maybe we should do some more research and run more studies, eventually end up in clinical trials for some of these things and translation. Was there this relationship with the social technological factors? What do we learn? And can sometimes we contribute back to psychological theory, learning theory, or we create information about design? And sometimes that is quite concrete, and some other times it's not so much. Okay, so the last piece, and it's not last because it should be last or it's add-on at the end. It actually should start from the very, very beginning. So these are the kind of questions that I've come across in my work, and I'll just let you take a break and read those for a minute. So we're dealing with emerging technology, marginalized populations. It's a strange marriage. And so we're coming from a place of privilege, a colonial worldview, and this all raises really interesting ethical questions. And I think it's important to take the time to ask them. And they're not really answerable in some ways, or that what I might answer might not be what someone else answers, but these things have become really important. And so when you're doing research design, there are ethical considerations that working with marginalized populations that you really need to think about. And there's a whole other branch in child-computer interaction just open, which we don't have time to get into, but how do we teach kids about the ethics that are embedded in technology? So that's a whole other lecture that we can give on another night. Okay, so here's some things. So psychology, Western psychology, was created based on Western educated, industrialized, rich, and democratic human subjects, most of whom were university students. Oh, now we're going to go work with very collective communities in a culture, in one of the world's poorest countries, in a culture I don't know anything about. And we're just going to import our psychological theory. Here's how you emotion regulate. These are the strategies. We know how to teach this. So it turns out not everyone's crazy like we are. or I am as a Western person. So this perspective is really important to kind of take that step back and think about all the assumptions behind what we think we know people should learn, how they should manage their emotions. So this is why in Nepal we spent a lot of time up front. Like, what does it mean that we're going to help? Who's helping who, really? You're helping us do research. We're helping you. There's a lot of trust building that has to happen, and you really need to work with the community step by step. So this is the whole participatory piece. And again, giving back. So anyone who's worked in development knows that there's this commitment to capacity building on the ground. So you don't just walk away and go, thanks for the research study. You make sure you've left things on the ground there that are super valuable to them. We try not to do harm to kids, and it turns out this comes in like interesting ways. This is like, I'm like, do harm? They're riding this car without seatbelts every day to school. This is their taxi. I was like, I'm not doing any harm. But it turns out there were things that were harmful, and one of the things that I've learned, I learned this at an orphanage, is they didn't actually want people coming in and volunteering their time for a year in this orphanage with these kids because these kids are so traumatized, and so their attachment is so sensitive that they form tremendous attachment to people. And then you go home, right? Go home after 6 weeks or 3 months or a year, and it just destroys them, right? So some of these kids, this is what I was told. I didn't know this, right? Some of these kids spend their whole lives waiting to be adopted, someone to come back and get them, or they form this really strong attachment. So to run this study there, we actually had to not run the study. We had to train the people there to run the study, which again is about capacity building. So these are these kind of really interesting ethical issues that completely steer the course of your research. And then the best question, I'll just leave you with that, is like, how do you get consent from a 7-year-old who doesn't speak English and never seen a computer before in a culture that values community consent, not individual consent? And then get that through SFU ethics board, which I happen to sit on. Lots of interesting questions. And then giving back. So I have permission to use this photo. And I just want to mention this, the leaving behind piece. So in this case, we didn't just leave behind training and gear and helping the kids. We said, is there anything we can do for you? And it turns out that if you have a clubfoot in Nepal, you're pooped. So you will most certainly live a life of poverty and be ostracized. So this little person, who I had to work really hard not to get attached to, was the 7th child in a family living in poverty. And the school said, not her family, because her family wasn't paying too much attention to her, understandably, is that it would cost $2,000 for her to travel with her father to Kathmandu and have a surgery that would correct that. So I don't know how long that took me to raise on Facebook. 48 hours. Like, this is not a difficult thing for someone in the kind of privilege that I have with the kind of people I know. So life-changing for 2,000 Canadian dollars. So we asked, what can we do for you? I would never have come up with this, right? So I do think there's this really ethical responsibility to give back to these communities that we work with. Okay, so where does that leave us besides overtime? So we've got theory, which we can write up as various kinds of papers, like systemic reviews, design rationale papers. This is where you realize how many papers you can get out of doing this kind of research. We do get technical innovation papers, systems and testing, and these kind of venues. And then user study protocols, because they're all a little crazy, right? Working in these situations. And then the results get published. Come up with new design methods. How are we working with marginalized youth with mental health issues in theater? That's worth a paper. And then all the ethical pieces tend to not be obviously peer reviewed, but also important. And then I feel there's a strong contribution to get stuff back out into the world. Okay, so there's all these different kinds of papers that you can write when you're doing this work, which is a little different than if you're just going in and doing one little thing. Okay, so forms of knowledge. Papers, overrated once you get tenure and finish your thesis. We build systems, those go out into the world, and open source code, of course, sending that out into the world. We have design tools like design cards and different systems, UI, UX documentation, flow diagrams, all these things are forms of knowledge that we can put out into the world. But we're still sitting mostly in academia, maybe a little bit in industry. So how do we get out of that bubble, which I think is really, again, I think there's an ethical imperative to get our work out into the world. So we can give industry talks and collaborations, which we try to do. And of course, they take up time. Public outreach is really important. Community reports back to the people we work with, policy briefings, hopefully the government's listening. So there's lots of ways we can get our work, and this is not something you're going to do when you're an assistant prof or you're a grad student, but over the course of your career, you can start to take time for these things to think about what other forms of knowledge can I get out in the world, and then how do I get beyond academe with these things, get out of the writing papers at Chi, little hamster wheel. Okay, so this research is dedicated to all the well-being of all the children and all beings. Thank you.
So much, Alissa. This was a great talk, fantastic presentation. I learned a lot about your work firsthand, and not just through the papers that you publish. So at this point, we will go through a round of questions before we break out for some mini reception. Anuradha has a microphone there, so if there are people in the audience who would like to ask a question, raise your hand, and we will pass the microphone around. For those who are online, I will be looking at your questions here and trying to go through them. There are some excellent questions online. Feel free to add more questions to the Slido link. So please get started, and I will probably start with a question that is, well, we have a question in person, so we'll start with a question coming from the audience here.
Hi.
Hi, thank you for your presentation. I have a question. You designed that words in 3D, but we write in 2D. Is that 3D stuff actually helps kids to learn better for writing, or is it a disadvantage? Or did you even consider that for designing those words?
Yeah, so there is theory that suggests that being able to handle letters in 3 dimensions, this is a different way of interacting with symbols rather than flat 2D, which you can't touch at all. It has to be visual. So with kids with attentional issues, we want to switch, not be completely dominant on hearing and vision, but also bring in touchment as well. And there's theory that suggests that's a good idea. So that's one of the reasons that we did that. And of course, it has to transfer back to 2D symbols on a piece of paper. Turns out it does. Look, all their spelling tests were printed on a piece of paper. So in our measures, we're checking, does this transfer back to the task they actually have to do, which is not make the letters with our word or make the words with our letters, but they actually have to spell. It's a spelling test, just like you might imagine in grade 2, right? Spell the word game, and they have to write it down. So. But theory suggested that this was a good idea, and you can't tease these things apart. In my work, you can't tease these things apart to be absolutely certain that was helpful, how helpful that was, but there was enough evidence to suggest that that would be useful, and then we saw kids doing those things, so that's as good as we get. Thank you.
Okay, thank you.
Thank you. I can pass on the microphone to Hema, and I'll go to the online questions. So Alissa, your work, you've done a lot of work, obviously, with children. As far as I know, you're one of the few, or if not the only HCI researcher that has done child-computer interaction in Canada, which is amazing, and we applaud that. Can you share some insights on what are some of the hardest challenges? And you talk about, your work with other communities, but also within your local community. What are some of your more significant challenges working and doing this work with children?
That's a great question. So I was trying to give you kind of the insight view of what I do because we don't write about that. But I didn't get into the things where it was just like epic fail, right? So it could be anything. It could be technological. Like we had a whole system we just could never get off the ground. And that's so frustrating and you waste time. We have communities we work with where we get so far into the community and they just say, no, we don't want to do this. Indigenous communities, sometimes we didn't have strong enough relationships with them. We hadn't spent long enough. We spent 2 years and it wasn't long enough. And maybe they just never would have felt like there was value for them and you just have to walk away. So those are risks you can take a little later in your career. What's hard? I don't know if anything's hard. It's just not what you hope for. It's not what you expected, but it's just part of the process. I find working with kids just so fantastic. It can be hard. I don't know, any parent knows it can be hard, but yeah, I think you have to be strategic in terms of your career.
It sounds like you have to be very flexible.
And flexible, yeah, and you can't get too attached to anyone you can't try and put your agenda onto these groups. It's really important. You can't be like, I need to get tenure, I need a CHI paper, so we have to meet this week to get this thing off the ground. Like, you just can't do that.
Mhm. Thank you. Gemma, you have a question?
Hi, thank you very much for the talk. It was very inspiring. My question is related to the theories. So in your work, you use a lot of theories. Probably some of them will came from psychology or other areas. How do you approach contradictory theories in your research? What do you do in that case?
I think that's why, for the kind of things I'm trying to do, I'm trying to identify what are the challenges and then what might be the mechanisms that we could support. So that gets rid of a lot of the theories are contradictory at a quite high level, or they just operate at different scales, like a group level versus individual versus what's happening in your brain at a neural level. So they don't always agree. There's not entirely agreement about what causes dyslexia and then how one should tackle it. But we did find there is a program that seems to be widely, anecdotally and widely throughout English-speaking countries be quite successful. So we did look at that and see what they were trying to do and then think about, well, how can we do that better? But at the end of the day, it's your research or hunch, right? You have to, you can look within a community, and this is why having an interdisciplinary team is so important. So, for example, within early language acquisition, we had a world expert on the team, and she had her way of thinking about things. But also, you can ask, like, you can really explore these issues, and is there other ways we should be looking at this, and have those kind of really productive dialogue. But at the end of the day, you have to put your skin in the game and go, okay, we think we're going to give it a shot and see what happens. And I'm always saying with my projects early on, I don't really say this anymore, but early I was always saying, this is never going to work. But being willing to try that and understand that that's science, that's research, that's design. You try it and see what happens. And sometimes it not working is just as valuable as it working.
Maybe Alex has a question. But before that, I'll go to a question online. There's a question here which says that, and it's true, we can see this, that the prototypes we research take a lot of time and effort. First question is around this theme. How do you ensure that you have built the correct prototype? What constitutes a correct prototype?
Right. That's a great question. That's a really great question, and it's so critical. So thank you, whoever asked that online. We never know for sure, but we do a lot of kind of really collaborative argumentation to make sure that the way that we've interpreted these mechanisms and the design strategies is fidelity to the original thinking there. So we often see like someone takes a theory and then they do that with it because they're a HCI researcher and maybe not an experimental scientist or a neuroscientist or something. So we try to make sure we've got that fidelity and we bring in experts to do that. So there's the first level. And then we do lots of early studies with small groups of kids. And I think my son is watching this talk. And when he was quite young, he's now all grown up. But when he was young, he would laugh that he and his brother were my lab rats, right? So I would bring them in and go, okay, you guys do this thing. We'll see what happens, right? And if it just completely like epic failure, you're like, we're not done yet. So those are two extremes. And then all the kind of human-centered work in between that happens. At the end of the day, you don't know till you run the field study. And even then, things you can go, oh my God, we just changed this. So we have a master's thesis out of my lab with phonoblocks. It didn't work, and then we realized we had to change a few things in it. And this is valuable knowledge, right? So.
And there's a follow-up to that is after you have these prototypes working and tested, and I think the validation you propose here sounds interesting. Do you patent them? How do you let the communities use them? How do you make them accessible?
That's a great
to communities
question.
at large?
And yeah, so in my earlier life, I came out of industry, and I was like, well, I want these to get taken out into the world, and I'm going to write innovation to commercialization grants and get these systems out. I came from a startup mindset, and it turns out that was just so difficult for this really early stage research. There's no uptake, there's custom things, and then I'm explaining to patent lawyers why this particular way we did it is interesting. At the end of the day, for me and what I'm interested in, I had to put that aside, and I do feel kind of sad about that, but it was a rabbit hole. And I had to just trust that I'm putting these things out there. My favorite example, I don't know if you guys know this history, is that the touchpad, which is now on all your phones, right, was invented at Xerox PARC in the 1970s, and nobody really thought it was good for anything. So I try not to worry about that because I've realized I can't do that with really early stage innovative work. I can't also be going, how do I get this out in the world? How do I take this to market? It's just way too early. Instead, I'm going, let's show some of the things it can be good for and put it out in the world. And it's a really different stance. And it took me a while to get there.
Alex? Sorry, Alex, yeah. Is it on, maybe? Yeah, thanks.
So that was pretty much my question.
Mm-hmm.
The relationship between the prototype iterations
Mm-hmm.
and also the product living in the community.
Mm-hmm.
Because from some of the examples, it does appear like that the project, especially the one in the town,
Mm-hmm.
had actual life
Yeah,
and what sort of impact
for that community.
for that community.
Yeah.
And I'm not sure how other projects, like the letters,
Mm-hmm.
what's the value of
Mm-hmm.
actual product living in the community
Mm-hmm.
beyond the sort of write a paper,
Mm-hmm.
academic papers, and share your research.
Mm-hmm. Yeah, I think that's really great. So sometimes I think my experience has been that when we've cobbled together existing technologies that are being supported by multinational companies, that's going to have a better chance of living on because we're not doing all the software support on it. And so, for example, in Nepal, after we left and a year later, they took our work into some of the jails and worked with youth there. And so there was this about 5 years in which we tried to support the software as best we could. They weren't upgrading anything because they didn't even have internet half the time, right? So they were able to just use a stable system for quite some time. So there was some value there. It's one of the reasons I think they agreed to do the project. The phonoblocks, the spelling and reading was much harder. It was so custom that it was really a proof of concept. It was never meant to be a product because if you were going to make a product that was going to go into schools, it can't be single use. It has to be stored in it, and if it is single use, it has to be about this big to be stored in a closet somewhere. So we did take that and we had this idea to use augmented reality, use a tablet and fridge magnets, and we looked at different technologies, and we just couldn't get it to be stable enough at the time where we had a system that could live in the community. So that really had to stay as a proof of concept. So that was a technological failure at that time. We couldn't, with 3 different technologies, we just couldn't, kids are holding a tablet over fridge magnets, they don't have dexterity. It was really difficult, but it had to be like tablets that they're already using, fridge magnets that they already have in the kindergarten class to work in a classroom. But that's never been my agenda going in. So.
Thank you. So maybe Risha, but before we go there, so Alissa, you come from a very interesting background. Talk about startup world, and I know there's some budding entrepreneurs over here who have launched maybe startups or thinking of startups. How do you see the relationship between sort of what you have done in the past world with academia, and do you think about going back into that world, or do you see it both as part of one world?
Wow, I have to think about that. They are one world. But I'm firmly planted in one. I want to do things that I can't commercialize. I want to do things that a startup could not get off the ground, no matter what superhero team you had, because I'm interested in things that are really showing what we can use new technologies for. And that is not going to be a product at this stage. It's a proof of concept. So my advice would be, as a startup person, if you want to do something, it should be incremental. I mean, I went through this at the beginning. It should be incremental. It should be on technology people already have in their hands. You should have some easy way of distribution. You should have time to do, like, we do have really good funding programs, innovation to commercialization, which I applied to earlier in my career and worked on that. But it's a full-time job, and that if that's something you want to do and you feel really passionately, and some of my colleagues have done that, they've taken an app and got it out into the world and still managed to get tenure. But it's actually rarer than you would think. It's one of the things that caused me to really challenge my assumptions. It's not in my field of child-computer interaction where you think, how hard can it be to get a great educational game out into the world? It turns out it's actually very difficult. Will I go back? No, I left for a reason. I left because I wanted to take this ethical stance, as opposed to yeah, there's no, this is what's right for you, right? I mean, at the end of the day, the ethical stance lets me sleep at night. Whereas when I started out, it was that I want to get these things out into the world and change the lives of millions of children using my products. But it turns out that I didn't think this was the right way to do that. So it doesn't mean it's not. It just, if you're trying to do really, really innovative technology, that might not be a very good idea.
Yeah, thank you for the talk. That was brilliant and very insightful. I wanted to ask with regards to, so generally with your projects with Phonoblock and Mindful and so on, there is a sense of there are these children who are facing these troubles, and so we can find these technological solutions and maybe even working prototypes to try and help them through their process. How does, and I believe one of the pointers that you had mentioned was with regards to, you know, reducing the amount of human workload, or trying to reduce the amount of effort that it takes from the human participant to help and assist. But what about the identification part? Like identifying children who are facing the issues in the first place, especially in communities where there isn't as much of an individualist focus as in North America.
Like, they have 3 different answers to that. So first, I just want to clarify that I don't think you can go in with technology and solve a problem. It's always a socio-technological solution. There's always and I've written about this, like rapport is important, like the learning design is important, all these other pieces. And I'm not trying to get rid of the human, like in Phonoblocks. What I'm trying to do is make it, and both Phonoblocks and Mindful, is that I want not a highly skilled person to be able to walk a kid through this intervention. So not nobody, but not like dyslexia tutors are hard to find, and you need so many hours with them, which makes it not possible. But if you had a teacher's aide, so we did studies with teachers' aides running our system. And so I just want to clarify that. It's actually really important to me. I don't think technology ever is the solution. It's always a socio-technological solution. Okay, now ask me your question again. The second part.
No, so sorry for the confusion.
No, but you kind of went down that path, and I think it's important to correct.
My apologies.
No.
Yeah. So yeah, with regards to identifying the children who are
right.
facing the issues in the first place.
Yeah,
Say issues as a very generic.
And then you asked about collectivist societies. So in Nepal, it was the school counselors that identified this problem they were having with the children there. So they identified the children, which is usually what happens, is that caretakers are identifying children and saying, can you work with all of them? So I got a review back from a paper that I did on focusing on the attentional piece of Mindful from I won't say where it came from, but an ACM conference. And they said, well, you didn't work with kids that had been diagnosed with ADHD. So how do you know they had attentional issues? And they just like wrote the whole thing off. And I said, exactly, because they can't get diagnosed. Those are the kids I want to work with. But if you go into a classroom, you know, in Bella Bella, in Burnaby, you know, in Nepal, and you say, where are your kids that are highly anxious and attention? The teacher's just pulling them out at you and saying, here, take them. Right? Like, so we rely on the community to identify children that maybe haven't gone through a formal diagnosis. And those are the kids I want to work with, right? We actually had one student who was diagnosed with ADHD during our study, and we had to take them out of the sample because then they're getting all these interventions and support. But so unusual, right? For every one that gets pulled out, there's 100 that don't, that never get diagnosed. That's who I work with.
Right. And quick follow-up, is that something that interests you as well in trying to identify or trying to help, you know, from a technological perspective, to help identify children who are facing certain, let's say, attention issues or, you know, therapy requirements and so on?
Sorry, what's the question?
So just as you've worked on developing these prototypes to help cure certain conditions, what about identifying those conditions in the first place?
Yeah, so I just want to clarify, I'm not interested in necessarily, this will sound really bad, but I'm not interested in helping cure anything. I'm interested in creating proof of concept tools that might be useful to other people to help children. And the goal of my research is to see if those tools are worth exploring by other people. So my goal is not directly to help kids. Of course, the kids we work with, there's benefit usually, but it's a very small group. So 50 kids got help somehow. and I'm sure it's great for them. Yeah, I haven't been involved in diagnosis at all. It's just not what I do. And again, I'm not really doing applied work. I'm doing very future-oriented speculative work to open up design fields, which is really different than doing clinical work, which is what you're talking about. It's like the opposite end of the spectrum to clinical work, really. And they look the same, but they're not actually.
Thank you.
Yeah, thanks for your questions.
Thank you. Just one or two last questions, and there are great questions online. So for those of you online, I apologize for not being able to select yours. I don't know whose it is because they're all anonymous. So I'm just going through it randomly and trying to blend it with the ones out here. You talk about ways that your work has led to lasting change or policies, updates, or things of that sort. Can you think of one example where that took place? And what do you think was the most critical component of that?
I can't think of an example because that's such a difficult thing to ever really measure or understand. So when you're doing early stage work and you're doing really speculative work, it's very difficult, I think, to know for sure that you've gone out and some government policy is based on you. I mean, you can pitch it at them. So I think in some ways, like the policy briefing we just did for CIFAR on kids and AI, and the piece that I was involved with that was what are the ways that, because I work in co-design and participatory design with kids, what are the ways that we can involve children in the dialogue about policy in the Canadian government? How do we involve children in that so we're not just coming down and saying we're going to use a rights-based approach and we're just going to mandate you do this, this, and this? How do we get children's voices in that? I have no idea if that was effective yet. So it just got released. But that, I think I feel quite hopeful about that. But it's so much work always too. So if you can just create legislation that's regulatory and nobody over the age of 10 is going to under the age of 10 is going to do this thing, that's so much easier for the government. But you have to, just because you're not sure it's going to work doesn't mean you don't try and you don't keep trying.
Thank you. And so I think we're getting ready for the reception, but I'll have to ask this one last question because everybody's asking this. And the last question is, how do you think AI can help your research?
Oh my God. That's really, so I have been working in AI, both for the government and then in our own lab. I think that's out of scope. That question is out of scope. Okay, and I will answer it a little bit. So this is a personal answer of some of the ways I use AI. So we're studying it in my lab, so that's different, but I don't think that's the question. The question is, as a researcher, how do I use it? So as someone with dyslexia, I will write grant. I'm running a grant right now, as we always are, or a research paper, and I'll take a chunk of it and I'll get kind of what I want it to be right, and then I just feed it into ChatGPT and say, okay, so give me check the spelling and grammar. As someone with dyslexia, there's always all sorts of things I don't see happening, and give me a revision list based on spelling and grammar alone, or give me a revision list based on spelling and grammar, making it more concise, and then I see what it gives back to me. So that's like a fantastic writing tool for all of us with dyslexia or who have trouble writing, or English is not your first language, where you're feeding it your writing, but asking it to tutor you, essentially. So that's an obvious low-hanging fruit. What else? Yeah, I mean, there's endless things that we can use it for in terms of writing code, which we haven't yet, but writing code, writing data analysis code, just checking what's been done on, really quick check what's been done on this, this, and this. I mean, you don't always believe it, but, lots of things like that, I think. I think there's probably things. So one of the ways we're using it in research, I will say, is that one of my students is really interested in design for disability and then working with kids. So how do we get kids who are studying design curriculum, which starts in about grade 5 in BC, how do we get them to design better for disability and have more empathy? And so they created a chatbot that was a disabled grade 6 kid that became a member of the design team. And then they ran a study to see if there was efficacy there. So they created the chatbot, and they based it on interviews with people who had low vision, both parents and children, to try and make it as realistic and non-stereotypical as possible. And then they looked to see things like, did it change their model of disability from a model which is like, we need to fix it, we need to cure your disability, to one in which we provide accessible supports in the community? Do we see that kind of shift? So that's it's a research question answer, but using these tools as helping us design and creating more empathetic designers, that little guys, but then they become engineers and things. So
Very good. I think with that question, I would like to again thank our
thank
speaker,
you.
our visitor. Thank you all. I'd like to thank those who've joined us online and our two support technicians and also Sharif, who was away. With that, I'd like to also hand over small
Thank you so
token
much.
of appreciation for your time to come out to
Thank
the
you.
Okanagan with some local gifts for you to appreciate. And at this point here, I'd like to now welcome you to the reception. The table's going to be outside. And we also have the patio until it starts raining. Or
Till the thunder showers.
whichever comes first, the rain or midnight, whenever. So please help yourself, mingle around. If you have any other questions, I know it's a good mix of faculty, students, and others around here. So just feel free to mingle around and hope you stick around for the refreshments outside.
Thank you so much for hosting.
You're welcome. Thank you.